welcome to another round of the OAuth Happy Hour. I'm Aaron Parecki, and I am joined again by Vittorio.
Ciao, Vittorio here.
So glad you could be here. Thank you all for joining, and as always, feel free to drop in questions in the chat, and we will talk about OAuth, OpenID Connect, security, APIs, whatever you want to talk about. And we will also be sharing some updates about what's been going on in the world of OAuth. It's been an interesting week or two, so we will have some fun stuff to cover there.
Most definitely.
Most definitely. So with that, let's see. First of all, let's start with some of the easy stuff. Any new spec updates? Anything new in the world of what the OAuth group has been working on for the specs?
I have to say that I haven't been very diligent in following the list. I've seen that the list has been very active. As in, I think that PAR is moving forward. Was it PAR, the thing that was mostly discussed?
I think so. That sounds familiar. And your JSON Web Token access token spec has been moving forward as well, right?
Yes, it did. We got, and I say we, but I should say I because I'm just one lone author. But months ago, we got the ISG approval. And so basically now the thing has been moved to the Rfc Editor. So allegedly it's only a matter of fixing the language. But although we got all the ballots for voting through, I still had a number of comments from, in particular, from a security person in our area that had some interesting points, mostly clarification. So nothing that would change the normative nature, but it was mostly like important things. Like, for example, there is a part in the spec where I say you should treat error situations in the same way in which you see those described in the OAuth bearer token usage. And the thing is that OAuth bearer token usage is designed to deal with bearer tokens, but the access token spec is not limited to that authentication scheme. You can allegedly use any other scheme. And so...
so hold on. I didn't actually realize this, because all uses of JSON Web Tokens for access tokens that I've seen have been bearer tokens still. Yeah, they have a structure, but they're used as bearer tokens. So are you saying that there's a way to use the JSON Web Token spec that you've written with some form of client authentication in the token, yeah, so it becomes not a bearer token?
Absolutely. So if you're using MTLS, which allegedly takes the bearerness away from the token, MTLS doesn't really go much into the details of what's inside the access token. Well, it does say that you do need to have a pointer to the structure that will be used for binding the token to the certificate, but it doesn't go into any of the details. Like technically, it could use any access token that OAuth accepts, and as part of that, the JWT just happens to be one particular case. So nothing prevents you from using MTLS or BPOP, DPOP, or all these new techniques that MTLS is not that new. But anyway, the main point is the fact that you're using JWT to encode the access token doesn't prevent you from using any of these other techniques. And so by referring to the bearer token usage, there was potentially a risk of people misinterpreting and thinking, oh, wow, I can use the JWT access token only with a bearer as an authentication scheme. And so Benjamin called this out, and so I updated the spec by calling out saying, hey, here I'm only talking about the 3 error messages that are defined by that RFC, but you can use this on any, not only with bearer. And I think I added something like 10 or 14 of those updates here and there, which are all clarifications, or like my classic Italian in English. My written English is not fantastic. And so occasionally I write things that are not, like I will use a 2 instead of a 4, or I will
Yep.
not do an ing form. And so very patiently, people call those things out, and then I just go and fix them. So that's basically what happened, but the substance didn't really change. So if someone already implemented that spec, which I know some people are out there, then that implementation keeps working. So don't worry, there are no changes.
Okay, good. So that's good news. Can you back up a second and explain the process that we're in right now of the sort of last couple steps? So we've got to the point of the OAuth group. The people in that group have all agreed that this document is in a good state and ready to be published. How do you what's the finish line look like? What's that?
So this is the first time for me as well, so I might not have it completely right. But as far as I understand it, at this point, the content has been deemed, okay, we discussed this, we reached consensus, and what the spec says is what we wanted to say. So now this moves to the Rfc Editor, who will use a very fine comb and make sure that we use exactly the conventions that ITF uses, that all the references are in the right place, that all the things that we had to put in the IANA, as in like we registered some claim types, which we also got approval for from the cadre of experts in there. But there is like a formal step in which you have to make sure that everything is in the right format, that the language is absolutely solid, all of that. And so my expectation is that the Rfc Editor, which is someone who's like a position occupied by someone in particular for our area of the ITF, will comb through the language, will do some back and forth with me, as in like, I'm doing this change. Is it changing the meaning, or like, is it all fine? And then once we reach the end of this, then this will be declared in a RFC, in a recommendation, and then that's it. It will become untouchable. And then if we wanted to amend or do anything, we needed to do something else on top of it. Kind of like what you guys are doing with OAuth 2.1.
Right, where there are several things about OAuth 2 that we would like to change, whether that's the way it's described or removing things. And there is no way to update. You can't change RFCs. They're set in stone. So also there's been several errata. That's the other way to sort of, I guess, change them is filing errata against the spec, which means I found a mistake and I would like to report it. However, those don't even actually modify the original RFC. They just get kind of linked to. So the original document will link out to its errata, and then people can see what if people already reported is wrong with the original spec, but it never actually gets incorporated back into the main text. And those things can only be basically typos. Like, you can't do any functionality changes as errata. It has to be, oh, this word was wrong, or you meant this, but you wrote this. So you can fix it, those kinds of things, but you can't do big sweeping changes with errata.
Right. You are not supposed to impact the semantic or the layout that goes on the wire. Like, all of that stuff becomes sacred, which is also one of the reasons for which I tell myself that, yes, it's worth it to go through this painstaking, slow process, because it's worth it. Like, once we get to something that we say, yeah, we commit to this, that is stable and people can rely on that, and software will not break. Well, it might break, but it breaks because implementers make different choices. It's not because of a spec, which, by the way, sometimes we are not as prescriptive as we could be. And so we leave leeway, and then that's where the problem happens. But that's a problem for another day.
Yeah, exactly. Well, great. That's good. Good updates on that spec. I just remember there was another one which I've been working on, which I can't believe I forgot that was within the last 2 weeks. These are the active, most recently updated drafts from the group. That's one we've been talking about, JSON Web Token Profile for Access Tokens. This is one that I've been working on for quite a while now, which I believe we talked about this last week, since there was some relevant discussion happening around it. And I published a new version of it on the 17th, which was 10 days ago. And
Very nice. What did you change?
well, it actually was not. It was mostly not my own work. It was actually mostly from a contributor who did a lot of very, very nice things to it. So we have, where's my document history link? This is the changelog, which will be removed, of course, in the final, but this is keeping track of what's going on in the draft. So mostly it was this. Mostly it was updates to bring it in sync with the security BCP, which had evolved several iterations past when this one had been updated. So this now properly matches those recommendations. There's that reference to the new ISS extension as well, since that's relevant here and it's worth pointing out. And then mechanical fixes.
Should we expand on what the ISS extension does?
Yeah. Did we talk about this before?
We might have touched on it really, really briefly, but I think that it's just like mentioning very briefly what it does. I think it might be useful context.
I agree. So, do we have that in here? We do. Do you want to give the summary?
I think that you are closer to it, so I'll give you the honor.
So this is the idea with the spec. It's relatively small, but it is adding a new parameter in the authorization response. So when your app has sent the user off to do the OAuth flow, and then you're waiting, they've disappeared, and you're waiting for them to come back to your redirect URL. In normal OAuth, you would get back the authorization code and the state parameter. And those two things by themselves don't really tell you anything. So you don't have any way to know where they're from or if they're legitimate or any of those things. It's very easy for anybody to send anything to your redirect URL because it's not an authenticated request. So this is normally not a problem, except if your application uses the same redirect URL to talk to two different OAuth servers. So if your app is set up to send people out to GitHub or to Twitter, Twitter's a bad example because they're not OAuth 2. If your app is set up to send people to GitHub or to Google, and if you've used the same redirect URL for both of them, then when your redirect URL is visited by the user, you don't actually know which server it came from. So you can't tell if it's Google or GitHub because it could have been either. And there's the particular attack that you can use, like take advantage of that for. I don't remember all the preconditions enough to set up to describe the actual attack, but that's kind of that's the problem that is created that lets the attack happen. So the solution is that there is a parameter added. So in addition to code state, you would now also get ISS, which is the identifier of the OAuth server that is making that request. And this is the part that I keep not being able to get my head around, which is how this actually solves the attack, how this prevents the attack, because I keep thinking about it like, oh, well, that's just external untrusted data again. How is that going to solve anything? Because anybody could just fake that parameter. But apparently it does solve the attack because of something that I always forget how to describe. So
I don't remember the network details for this, but in terms of scenario, the way in which I understood this was that this was really meant to be in a multi-tenant scenario. Like say that you have one app that, like, I don't know, an app that does HR and is exposed as a SaaS app. And so multiple companies use it. And those companies might go through one single, let's say, facade authorization server. And this facade might actually redirect you back to your, for example, your own provider. So that the company A, once they hit your app, and as you say, this app has only one redirect URL, they eventually sign in with their own identity provider, and then company B does the same. And but so they hit the same app, the same endpoints, the same redirect URL, but they actually sign in using their own identity provider. And the idea, again, is if I understood correctly, is that once I receive the issuer, then the issuer will actually specify whether it's company A or company B. So when I reach out for the authorization server, then I will reach out to the correct one, like the one that is actually A or is actually B. And then at that point, I'm actually doing server validation, authentication, because I'm opening an HTTPS channel. And so these things should help me to prevent a situation in which someone from company A somehow pretends to be from company B and access the app using the tenant B substantially. And normally you wouldn't be able to do this because you'd have, it would be completely opaque. As you mentioned earlier, it's just the code. And so the expectation is that there is just one token endpoint that I can redeem this thing for. Whereas now, potentially, I can choose a different endpoint. Or I'm not sure if that spec includes sending the issuer all the way to the token endpoint. Honestly, I read the discussion.
I don't think it does. No,
I haven't read the spec.
Yeah. The relevant part here is, I guess there's two parts. There's the OAuth server is going to be sending it, and then the client has to validate it. And this is the section that talks about the client validating the ISS parameter in that request. Basically, it says, if the value doesn't match what you expect, then don't proceed. Don't send the authorization code. So if the client has started the OAuth flow to a server that it knows about, and it gets back the redirect and the ISS is different, then stop. That's what it's telling you to do. Well,
here the thing then, the scenario that I mentioned earlier might not be addressed, because the point is, unless your application has a different URL, like company A.hrsaasapp.com, company B, and then at that point, you can do what the spec just said, as in, if the user started with company A.nameofmyapp.com, then I know what is the expected ISS value. If instead you'd be in a truly generic situation, like, I don't know, imagine that the app is a content app. And so the URL of the article behind a paywall doesn't change the path depending on who's the consumer. So at that point, the issuer is more of a matter of, is the issuer someone who paid the subscription? Like it's a company that is paying the subscription. Then it might be hard to know whether it's company A or company B if they both paid.
So all of this is also to say that this is really only relevant if your app uses more than one OAuth server and you use the same redirect URL for all of those OAuth servers. So if either of those are not true, this is basically irrelevant. So if you're using different redirect URLs for each OAuth server you're talking to, you already have solved the mix-up problem. And if you only ever talk to one OAuth server, you don't have a mix-up problem to begin with. So this is definitely more of a...
As long as that one server is not is not just a facade for a number of different ones. Because that is unfortunately a pattern that you find in the industry. Like, without naming names, there are products in which you reach out to the metadata, and once you get down the metadata, in place of the issuer, there is a placeholder, which basically says, okay, here there's my authorization endpoint, here there's my token endpoint, here there's my signing key, but...
those are actually from a different server?
Yeah, expect... now, those are all from the same facade, but this facade can act on behalf of different companies. And the only thing that tells you this token is coming from a different company is the value of the issuer. And so if you were to use software on your client, like now I moved it to OpenID, but it's kind of similar. If you were to have something which says, okay, let me consume my metadata, I expect to validate the token using the stuff I find in this metadata, you'd have to use all of that, like the signing key, the subject, all of that, but you'd need to do late bind for the issuer value, because this issuer might be different depending on the company which is being accessed in there. Again, highly non-standard, but it is common enough on the market, which is worth calling it out.
Okay. Yeah, it's interesting. Definitely tricky stuff once you start getting into multiple different OAuth servers, multiple complicated relationships between these parties. it becomes very confusing very quickly. So anyway.
It is hard, yeah. In fact, like, just to give a concrete example for this, in Auth0, we just recently introduced the ability to use organizations, which basically is projecting what I just described. As in, have one app and multiple consumers of this app from multiple companies. And the way in which we express the fact that you are coming from a different company is a new claim, which we call organization or something like that. So you can use the same usual infrastructure that for validating tokens, and the information for this is in a different claim, so that we don't really break the standard. But if it makes a difference for you to know from where this thing is coming from, really, then there is an extra claim. You can just deal with that. I think it would have been nice from the specification offers to actually talk about the multi-tenant case explicitly. But the reality is that when OAuth came out, this thing was largely for websites, definitely single tenant, and very often authorization server and resource server collocated. So I think it's unfair to ask from the framers of this stuff to already think about a world in which SaaS is now the preferred way of delivering software. So maybe it's time to think about some updates, some extensions in there, but for the time being, it's kind of left to everyone to solve this particular problem because the spec doesn't tell you how.
Yeah. Could be some extensions. Could also be a best current practice document that kind of just points out all these issues without providing any new new mechanisms, just sort of pointing out all these issues and saying, here are some scenarios that are common in the industry. Here are things to keep in mind as you're doing that. Here are some tools available to you, pointing to extensions that do exist. So yeah, definitely some opportunity there, I think. But we were talking about the ISS parameter because it was linked to, it was added as a reference in the browser-based draft I just updated. So that was that was a whole long diversion to explain that bullet point. Really, it just says, by the way, this thing exists. You should use it if you have these situations. And then a lot of just cleanup of the language and clarifications of things. So.
Well, I do see one very important change, apparently, the one in which you move from should to must for the refresh token. That one is very impactful.
That is true. So this was part of the updating to match the security BCP. So for single page apps, then you either have to use refresh token rotation or sender constrained refresh tokens, since that's what the security BCP says, which is, yeah, that is a significant change there.
I think it's a fully justified one because, as we know, the browser is a pretty unsafe neighborhood, and so basically, with rotation, we get leak detection, which is so important in that context. Or sender constraint, even better. But every time we add the sender constraint, I smile a bit because it's not very actionable today, right? It's more of like
it's
a
future
proofing.
Yeah, it is a bit of future proofing because there are multiple efforts in the works, right? There's Depop, which is very early stages still, but a good solution. There's also now new movement on HTTP signatures. So I'm actually really excited about that one, where hopefully there will be a stable spec to do generic HTTP signing. And hopefully it's generic enough and low level enough that it can get built into HTTP clients themselves and not something that app developers have to do. So as an app developer, you would just have to provide the keys for it, and then the library would do the work way down at the lowest level, down in curl or whatever actual HTTP client you're using. That would be, I would love to see that. Obviously, we're still a long ways off from that, but the important part and the relevant part is that the draft that has the most recent draft that has been worked on for that has also now had another round of updates in the HTTP group. So that is good to see some progress there. But neither of those are really usable right now, at least not in a way that is guaranteed to be stable over the next 2 years. So yeah, adding sender constraining into recommendations for browser apps and even somewhat mobile apps and just in general, it's a bit of a future proofing. Let's call it that. It's aspirational, but
good euphemism. And just for exhaustiveness,
yes,
the MTLS is technically an RFC, but it's not really usable in the context of single page apps because PKI is PKI. And I don't know if you ever had this experience of getting the browser dialog in which it asks you to select a long GUID saying, hey, for this operation, the browser needs to know whether you want to use this GUID or this other GUID. Which one do you want?
The certificate prompt, the certificate in the browsers.
Yes.
Yeah,
and
that was never a good user experience.
Right. I imagine my sister, who's an accountant and uses Facebook, uses Excel, but that's as far as she ventures in the digital world. And I imagine her calling me and saying, hey, my browser is calling me names. So, it's not.
I wouldn't even know what to choose for that. It was a terrible design for that problem, and I guess it's why it got taken out, because nobody was using it because it was a bad design. So yeah,
it's for a different time. There's a time in which we were still using basically local networks, and this kind of prompt would be only in enterprise settings, in which like maybe you want to use like I remember this in particular because it was a flow in which in order to do a release, you had to sign the bits of a release. And in order to unlock the process, I had to use a smart card. And so the browser would prompt me and say, hey, I need this certificate in particular, and then you place the smart card. And this would, and today that's completely anachronistic. Luckily, there's WebAuthn and everything, so the browser can handle the experience way better. But back in the day, we didn't have all this fancy stuff. We had low-level certificates.
Yeah, so I'm hoping that, like, I think actually WebAuthn is a good example of that, where that is a good user experience for the end user, and it's built into the browsers at the lowest level, where like the iOS will use its own keys that it has, completely locked down, and it can sign things that the browser can use. And I would imagine that HTTP signatures could eventually fit in that world as well, of you have to do the OS level Face ID, Touch ID, whatever that prompt is, to unlock the signing key so that your JavaScript client can then use it to sign the HTTP request. And all that would happen without JavaScript developers really having to do anything except say, like, sign this request, please.
That would be really, really interesting. There are so many things to figure out because I know that the FIDO people had to wrestle with really interesting stuff. As in, like, if you're roaming keys or if you have keys versus the TPM of a device. And also, like, the access is, like, in order to get the attestation, there's like the access is really privileged. So the way in which it would be exposed to the browser would be interesting to figure out. But yeah, I think that you paint a picture that I really like, in which the developer just says, do this, and maybe just as an identifier of a key, not even and then the stack takes care of it without having to burden the developer with these low-level details.
Yeah, and I think that's only going to happen if it can get baked into the HTTP layer, where it's not for a particular purpose, the way that like OAuth is. I think it does need to get pushed down into the stack, so that it's just sort of it's there and it's available for things like OAuth to use when OAuth needs that property.
But you know what? When was the last time in which this thing almost happened but didn't? And now, if John Bradley is going to ever hear this, he's gonna place needles in my dough. Token binding. Token binding was a good multilateral attempt to do exactly that, as in push in the stack this capability, which was needed across the board. And unfortunately, everyone has its own take on this, but my take is that its own demise. Its demise was actually not everyone even agrees that it's done, but I am a pessimist, so I think it's done. And I think it was mostly because so many planets had to align perfectly in order to do this. And whenever you go low level, you need to convince the operating system vendor, the browser vendor, the network stack libraries, and similar. And once you manage to do it, it's a beautiful thing, and everything works seamlessly. But the process of making the sausage is very hard, and so it can go wrong. For a WebAuthn, gargantuan effort. It's going really well, but there is so much energy spent on this behind the scenes. And one might say that there was also a lot of energy with token binding, but for some reason, it didn't work.
It's hard to coordinate that many different companies and like get all their interests aligned and actually have everybody agree to do something at roughly the same time in order to make this stuff actually happen and actually usable. And I think WebAuthn is a fantastic success story because it is widely deployed now. It is actually usable. It is got good support by pretty much everybody, and it took a long time to get there for sure.
It did, and not perfect yet because of the account recovery. But I think that's really the last piece of the puzzle. Once the roaming and the recovery or like the account lifecycle part is figured out, and I don't want to reveal anything, but I am I'm the topic lead for Identiverse for a couple of tracks, lead and co-lead, and I think that we might end up seeing something interesting in there. Like I know that there's some movement, but I don't want to spoil the surprise or anything. But I think that it's going to be worth it to keep an eye in that space.
So what you're saying is definitely take a look at the talks at Identiverse.
Yeah,
absolutely. If you can make it, yeah, okay.
And it's going to be a hybrid formula this year. There's like a in-person part, which I'm personally looking forward for because I've been strictly locked in for 14 months. But there's going to be a virtual offering as well, just last year. And so everything that is done on site will also be available online. So that should be easy to follow.
Great. That's excellent. So yeah, that's good to hear. So we were talking about refresh token rotation and sender constraining tokens in JavaScript apps because, the sender constraining part of this phrase is a little bit early for that, which essentially means that today, in order to be compatible or compliant with the security of BCP, your single page apps will need to do refresh token rotation, which means refresh tokens are basically one-time use. Yeah,
which is a funny thing because, and I say funny in the not exactly a regular English sense, but the thing is that in order to achieve that, typically your authorization server needs at least some degree of statefulness. Let's say that you do need to keep track of at least the family of refresh tokens that you are issuing. And not everyone goes for that design because whenever you save stuff on the server, then you start having challenges in terms of storage, in terms of concurrent access, in terms of sharding, in terms of data sovereignty. Like there are a number of challenges in the implementation level that you have to deal with. And so not everyone has a server-based version. Some people will just place everything inside of a refresh token, encrypt it, sign it, so that it's opaque for the client. And then the authorization server, every time it receives it, opens it up, finds what scopes it was for, what resource it was for, and acts on it. And so for such people, for such products and technologies, adding rotation is going to be really, really hard, which is why, if I look in my crystal ball, I think that they'll just skip it and go straight to sender constraint as soon as they are viable. The challenge is that in the interim, their options are limited. They can choose to violate the recommendation, which is basically what's happening today. If you look at the number of SDKs out there, they get a refresh token. Maybe a refresh token has a short lifetime, but it doesn't rotate. So it's technically violating that constraint. The alternative, which is also not always viable, but it's possible, is using custom domains. Like in particular, like for some of our customers, the challenge, like you can still use potentially iframes for getting new tokens. The point is that you can't use implicit flow because we said that we don't like it. So that iframe cannot be used for getting a token in the front channel, but it can be used to get the code. So technically, you could just have your iframe, do a code flow. If you are doing OpenID Connect, pass a prompt parameter and saying prompt none, and say, I don't want any UI. If you can't give me what I'm asking for without prompting, fail right away, so that I'm not waiting for anything. And normally, we no longer do this because with all the changes in the browser, given that it's an iframe, the iframe will have no access to your session cookie. And so when you try to get the code, and you won't get it without re-authenticating. But there is a trick, which is if you can use a custom domain and have your client, your app, and the authorization server on the same domain, then your iframe is going to be in the same domain, and so your browser will allow you to use this thing. So sometimes it can be done. Some other times you have multiple apps that deal with the same authorization server, and there is no single domain. Like imagine that you are a magazine. You own multiple magazines, and your users just go to magazine1.com, magazine2.com. If you have an authorization server shared across those, which domain are you going to choose? One domain will be able to be on the same one, but all the other ones won't. So
let's back up for a second. So I want to dig into the this cross-site cookie issue, because we've been hearing a lot about this right now because of the changes that are happening. So the thing that's breaking is cookies in iframes when the iframe is on a different domain, right? Is that the short version?
It is the short version and specific to this. In the general case, the thing that is already breaking today in some browsers, and will break for sure in all browsers in just a few months, is a third-party cookies, which largely means any operation which attempts to reach a domain which is different from the top-level domain will not, by default, carry the cookies, which those domains might have saved on the user agent when they were the top-level domain in some former interaction. So the iframe would be affected, but also things like if I have an image tag, and the source of the image tag goes to a different domain, even if my user agent has a cookie for that domain, I won't be able to actually send the cookie when I am retrieving the source of the image. And so the outcome is that whenever you're trying to reach out for a different domain, such as I am on the page of my client, and I want to go back to my authorization server for any reason. Maybe I want a new token, or I want a new code, or maybe I just want to verify that I still have a session, and if I don't, I want to sign out from the app as well. Unfortunately, this is a mechanism which is used also by advertisers to keep track of where the user is going. And so browsers like Safari and Firefox, they block the use of those cookies in this way. And so identity becomes a bit of a roadkill in here, like an unintended crossfire, like a friendly fire victim, let's say, in which I'm just trying to go back to my authorization server with my session so I can do something without bugging the user. Like imagine I'm a mail client. I want to see if I got new mails so I can update the list. The user is not clicking anything. I'm just doing this behind the scenes. I don't want to prompt the user for doing anything. Mm-hmm. And normally you want to be able to access that cookie. So behind the scenes, you can hit the authorization server and retrieve stuff, retrieve like your new token so you can make this call. But by the fact that third-party cookies are no longer attached to requests, the outcome is we can no longer do this. Hence, all the tricks that we described, or refresh tokens, all of that stuff.
So that's actually a perfect segue to the other new thing that happened this week, event that happened this week, which was the W3C workshop for identity in browsers. And this was a big point of discussion, I guess, a thing that sort of resulted in this meeting needing to happen. So can you describe what was the meeting, what was the goal, and who was there?
So what happened was that in the last few months, but I want to say in the last year or couple of years, as identity vendors, we often run into challenges because of the changes that the browsers are introducing, mostly for privacy protection, like the ones that we just discussed. And so we all had one-on-one discussions with, we talked with Google, or we talked with the Safari people and similar, and the same happened to other people in other companies that are either identity vendors or people that use a lot of identity. And so what happened is that we found ourselves more and more often in these kind of discussions. We brought some of these to some of the identity standard groups. So in the OpenID Foundation, we started having a special interest group for talking with browsers. We started as identity people to participate in some W3C groups, like the privacy group and similar. So there were a lot of parallel conversations, a lot of duplication of work, and a lot of discussions in which we didn't have the right people in the room. So what happened is that the Chrome team worked with Heather Flanagan, who's, I think, a former Rfc editor in ITF, and she helps facilitate events of this kind. She also works in higher education and similar. So she worked with Tim Cappali from Microsoft, myself from Zero-Octa, and Brian from Ping Identity. So in general, we all worked together to somehow put together this event, but she did everything, basically. Like, she set up this event, she contacted all the various players in this space saying, hey, we've been having all these conversations, you've been part of all of this. Now, we are trying to have 2 days of structured conversations in which we want to bring together browser vendors, which normally congregate in the W3C, identity people, which normally show up at ITF or OpenID Connect or the Kantara for the SAML side, and identity providers and publishers, which often don't show up anywhere. So people like Facebook, or people like Google as identity provider capacity rather than the Chrome team, or the Microsoft team, as in the Azure Active Directory team, not the Edge team. And so Heather managed this miracle in which it took these particles that normally don't want to stay in the same place. And instead, she just organized these 2 days. She built a pretty open agenda in which, day one, browser vendors described their current stance. The theme in general was browsers and federated identity. When we say federated identity, we really mean any scenario in which your application outsources authentication to someone else. So it's a very broad thing. It's not just federation in the SAML sense. And in day one, the first hour, it was Firefox, Edge, Chrome that went through their viewpoint in anti-tracking features that they're building. And here is the interesting part, new features that they are adding or they are incubating that explicitly implement identity. Today, identity is built on low-level constructs, cookies, decorated links, redirects, storage. Those are all primitives that are general purpose. They're not for identity. And in fact...
So this term decorated link, I remember came up a lot during the event, and I think there was some confusion about it. Can you explain decorated link?
Absolutely. Again, the way I understand it, decorated link is simply a link which includes extra information apart from the host and the URL. So if you have an attribute in the query string, or sometimes if you manipulate the host name for embedding information, but usually it's just the query string. Largely, it just means it's a URL where I'm passing a parameter. And when you read the literature from the browsers, normally they refer to these as a technique which is used for tracking. Let's say that I am in the website X. I wanted to let my own domain, that here there's the identifier of this user that I'm following in multiple places. I'll just add a query string parameter which says ID of a user is X, so that you can reconstruct your dossier on the server side.
I've seen a lot of these with I've seen this on Instagram where if you go and share a photo from Instagram, it'll add this IGSHID. I'm assuming it's Instagram share ID, and then 10 characters, and they're doing something.
Yeah, and this is the same. If you ever click on a link on the Facebook app, the thing that you see in there is not the browser; it's their user control. It's their web view control. And if you say open in browser, you'll have a URL, and there will be the big parameter which says here there's your kind of ID. Anecdotal evidence is I observed it while trying to share a link to someone, and I copied, and in the clipboard there was this thing. Yeah. But anyway, the highest of the bit is it's a technique for keeping context, for bringing the state with you.
Yeah,
and it's a bit of a challenge because the one thing that the user agents are looking at is actually detect when this technique is being used for tracking and then block it, stop it. Unfortunately, we also use these for sending client IDs, scopes, redirect URIs. So if this thing goes away, it becomes a big problem. But problems are even bigger. There is one thing called the bounce tracking, which is really the extinction level event for us identity people. We use redirects.
So wait, first, what is bounce tracking?
Bounce tracking is an technique which relies on redirects to track a user. Say that I cannot use the third-party cookies to phone home and say, hey, this user is on site A, write it down in their history. Say that I cannot do that because all these techniques blocking third-party cookies succeeded. One thing I can still do is to do a top-level redirect. I never know if it's redirect or redirect. How do you pronounce it?
Both, actually.
Oh, excellent. Good. So I cannot go wrong. So you can take where you are, redirect to your tracking domain, and there you'll have headers that say, I'm coming from this other place, you could decorate the link and similar, and then come back. And then at that point, you tracked. Now, if browsers start saying, hey, I see that you always redirect to this domain, so I'm flagging this domain as a tracking domain, so I'm going to do bad things to it, as in I will not store the state long-term. Now, that thing might be a tracker. It might also be your identity provider. And so if you get flagged, it becomes a very big problem. And it's difficult to think of a way in which we can model all the relationships between the various parties without redirects. Imagine the thing in which I'm in one app. I get redirected to my issuer. My issuer might be simply an aggregator, which offers me, do you want to go to Google or to company A or to company B? And once I click, I get further redirected. And if I go to company B might have something in the cloud which checks credentials on premises, because maybe you bought a RSA secure ID and you want to check the credentials in there. So you can have these long chains of redirects, and it's just hard not to do, how else are we going to do things? And the another thing that the browsers like to claim is this happens only for enterprises. And that's not true. I remember when HBO came out with HBO Go, which now is HBO Max. Of course, the first thing I did was opening the network thing of the browser to see what was going to happen when I would want to get in my browser to my HBO content. And this thing just offered me the home run discovery flow, saying, okay, are you a Comcast user? Are you like a DirecTV user? And once I said Comcast, this thing used SAML to get me to sign in to Comcast, and then come back and then sign me in HBO Go, now HBO Max. So that is the quintessential consumer-based flow.
That is a very, very much consumer use.
And you
can't get much more consumer than that.
Exactly. And you cannot say, well, Comcast, if you want your user to do this, you can just push a policy, a work policy or a school policy on the user's device so that you can allow this for your domain. That's just not feasible because
please install this provisioning profile from Comcast in order to log into HBO. No, don't do that.
Yeah, exactly. You just gave a classic example of an average American response to this. It's like, no, I'm not going to do it. But anyway, I went really far. But bounce tracking largely is the technique of using redirects for tracking the user. And bounce tracking protection would be features which are only in experimental builds today, and there are no dates for once they will come, but they are the things that as identity people we are the most concerned about. And browser vendors are open about the fact that that's what's next. Now we are talking about third-party cookies demise, but the next frontier is bounce tracking. But anyway, coming back to the workshop. First, we had all the browsers talking about limitations that they are introducing and new specialized APIs for identity. Things that instead of leveraging low-level primitives, they actually give you explicit APIs, like a sign-in API or authorize API. And
so can you share some examples of where they've done this before for other non-identity things?
This is a good point. I'm not sure, to be honest. Like,
I guess WebAuthn, where that's a UI that the browser has added, whereas prior attempts had to be built with low-level code. What about we're talking about things that the browser has? Oh, payments. The credit card autofill. That's another one, right? So credit card forms were previously always built with JavaScript and HTML. Each website had to build its own UI for that. There's the new payment API where ultimately it's still the browser, like your JavaScript code gets the credit card info at the end, but the UI for collecting the credit card info is provided by the browser. So
it's a good example. This is a good analogy. I never thought of it in those terms, but I think you're right. On the WebAuthn side, I'm not entirely on board, mostly because it looks like something which is an addition, like something that we couldn't do before, like using the key on your TPM or having a plug for keys. But I think that the credit card example that you gave resonates. The thing is that the credit card scenario is like a bonsai. It's like nicely self-contained, and the primitive is exactly there. Whereas identity is a universe of things. Yeah. Like one of the participants in the group spoke about over-the-top innovation, as in the people who created the platform, like the web, they didn't know all these other scenarios, and those scenarios organically emerged. All these amazing innovation, which fuels basically our civilization, because like think of all the things that we are doing online, all the web. It was all built afterwards with knowledge that could not have been done by the people, the framers of this thing. And even today, we don't know what will come tomorrow. So that's one of the big issues we have. Like the browsers are bona fide trying to add primitives to address the identity scenarios. And those primitives vary from really low-level stuff. Like there is a proposal from Google, which is called first-party sets, in which basically you do a bit like CORS, in which every domain can make a declaration, and you can say, I'm domain A, and I am the root domain of this cohort. Let's not use cohort because it's overloaded in there. It's of this group. And then you can list all the domains that you say, okay, those are the domains that I am the root of. And then each individual domain can declare, this is my root domain. And then if a user agent sees those things, then it will disregard the third-party cookies limitation and just go with that. And the challenge with that is that actually this was proposed, but the W3C architectural group pushed back, saying this fundamentally changes the concept of origin, and we can't go there. But this is a low-level example. I know we are almost out of time, so let me just mention the other example, which is WebID. WebID is a super high-level API proposal, which actually changes the way in which the UI is shown and changes the flows entirely. Like there are different stages and different levels of incubation, but the most extreme basically has the browser do everything. Basically, the browser is the thing that asks for tokens. The identity providers only give tokens to the browser, and then the browser discloses these tokens to the resource server or to the client. And it completely changes a lot of the flows that we are doing today, would make a lot of the things that we are doing today impossible. And the conundrum, which emerged when the identity provider people had their chance to speak, was that some of the things that the browser is trying to prevent, the identity provider won't by design. Like the browser says it should be impossible for the identity provider to know where you are going to use this token for, because it's the maximum level of privacy. The identity providers say, I need to know because there are business rules that I need to run in order to do this. There are information I need to place in the token in order to declare this. There are things that I might want to be able to revoke. And so I'm oversimplifying, but we can add the links to the proceedings of these 2 days. I think that it's a super interesting read. And also the players, like we had like Google, Facebook, Apple, Microsoft, Salesforce, like really big hitters. And so hearing their point of view is really illuminating, very interesting.
Yeah, it was an amazing collection of people for sure, and a group that does not meet very often together all in the same place. I'm going to drop this link in the description and in the chat, but this is the link to the event page for the event, and it links out to the GitHub that has, I believe, the GitHub page for the event has the minutes linked to it from it.
Fantastic.
There's that. If this doesn't yet have it, it will be updated, and as will this page. So take a look there if you are curious about finding info about that in the proceedings and the full minutes. It was a fascinating event, and very good that it took place, and I'm looking forward to seeing where that discussion continues as well.
Same here.
So with that, we are at the top of the hour, and thanks for joining. Thanks for the updates, Vittorio, and we will be back here again. The place to go to find the next, of course, subscribe to the channel. That will notify you. But if you want to get more of an advance notice, then go to octadev.events, and that is where you can find links to our upcoming calendar. You can even add them to your calendar if you want to. Click on the happy hour tag, grab that calendar feed, and drop it into your calendar of choice. And then you will see when we are doing happy hours next, which looks like our next one is June 10th. So it'll be a couple of weeks, and we will see what interesting things have happened in the world by then. So, yeah.
All right. This was fun.
This was fun. Thanks a bunch, and see you in the next one.
Thank you, everyone. Bye.